Hi, and welcome to the demo/guide to how to use Tauri. Tauri is a 3D data visualization tool that you're meant to use alongside fargO to visualize your protoplanetary disk simulations in real time and in 3D. So first, you are going to want to open a disk file. So you're going to load your disk. We're going to pick this one because it has a planet, and you're going to have your little environment here. You can resize your windows. You can move them around, although I don't recommend doing it for this tutorial because we're going to use their placement to help you move around. On the top left, we have the renderer controls. Then we have the data controls. The slice tree, which lets you see the slices you have created so far. The slice inspector is on the right to edit those slices. And then the camera controls on the top right. And in the center, you have your viewport where you're going to see your data in real time and control it and manipulate it. So let's start with the camera. To move the camera around, you press the left button on your mouse and move around. To pan around, you press the right key and move it around. You can zoom in and zoom out using your scroll wheel. And finally, you can snap your camera to different positions by pressing the tab key. Now, if this is confusing to you, you can also use the camera controls on the top right, where you can move the pitch around, the pitch of the camera, directly using this slider, the yaw, or the zoom distance. And you can also snap to different planets that are detected when you import your disk using the buttons directly. If you want more fine controls, you can go into the advanced settings where you can change things such as the FOV. So a very high FOV is going to look a little goofy perhaps, but very, very wide. And a very low FOV is going to look the other way. Or you can go all the way and change your camera to orthographic view. And in the orthographic view, perspective no longer exists. Distances that are far are going to be the same as distances that are near. You can also change the mouse sensitivity controls and the movement speed in there. But let's go back to perspective controls. This is how you move the camera. Now, if you want to view your data, on the left side, you're going to see the data window. In this window, you're basically seeing every scalar field that was detected when you imported your disk. And you can simply select them to view them one at a time. So let's say you want to see how density varies. Or let's say you want to see how velocity varies. Now, when you're seeing velocity here, the values go from 0 to 1, with 0 being light blue and 1 being very, very bright. It's up to you to know what 0 and 1 means. Currently, 0 means the minimum value that was found in your data, and 1 means the maximum. In the future, there will probably be a little number in the top here telling you what these values are. But for velocity, it doesn't make much sense to use this sort of color palette because what you actually want is for 0 to be in the middle and then -1 and 1 to be on the right and left. So to change this, you can go into View and Color Palette and select a divergent color palette. All these color palettes and their name and their colors are taken directly from Seaboard Plot. So you would probably be familiar with them if you're familiar with Seaboard Plot. Let's pick this divergent one. And here you can see how everything goes from one direction in blue, becomes neutral, and another direction in red. Now let's go back. The directions here are relative to the planet, by the way, which is why you might be confused. Let's go back to a different color palette. Let's go with Rocket. Okay, so now we have our data, but this is not very useful. So far, you're seeing your data in 2D, which is something you could already do, perhaps in even higher detail with Python. So if you want to see things in 3D, you can select your slice. You can go in the top left here and click the rotate icon. And now you have these handles that are created with the blue and the red handle. If you hold one of these and you move along, it will rotate along this handle. So you can rotate 90 degrees, for instance, and see how things are vertically. So this perhaps is an interesting one to see the theta velocity. Let's go back to a different color palette, a diverging one. Maybe something more bright. Yeah, this one. You can see how the vertical theta velocity changes. If you want to see both, you can just create a new slice. And boom, we have two slices. We have a vertical one, and we have an horizontal one. But we can go further. We can create a third slice. Click on it to select its inspector on the right, and then change the kind of slice we have. So far, it's a plane, which basically cuts through the environment as a plane. You can also pick a radial slice. The radial slice cuts the world along a radius. You can change that radius directly in the controls or by clicking the scale icon on the top left and changing it manually. To change between editing modes, you can also use the keys E, R, and T. T for translate, R for rotate, and E for scaling because it is next to R and T on the keyboard. You can perhaps move this little icon, translate it to where the planet is. A way of doing this that is easier is by simply snapping it the way you would the camera, but this time snapping a slice to a different area. You can also do the same for a horizontal slice. Let's snap this one here, and we can rotate it alongside this icon. Okay. Let's go a little further now. We've understood how to use slices. By the way, you can also hide them using these buttons and remove them. We've understood how to create slices. We understood how to inspect them and edit them, how to change the camera and the data. The last thing to look at now is the renderer. There are different rendering modes. Scalar field is probably the one you'll want to spend the most time in. It's the most useful one, lets you explore your data with the most context. But you can also decide to see things like the velocity. So whenever we create your disk, we import the velocity information, such as velocity, phi, radial, and theta. And then we let you inspect it directly using arrows. This is a little confusing here because we're using the same slices we just had, but let's take one. You can click it, by the way, in the viewport or directly in the slice tree. But let's take this one, snap it around our little planet. Let's remove the other one. Boom. And we can already see sort of the directional information of how the dust is being affected by the gravitational pull of the planet. But if you want to have higher resolution, I cannot click it. Can go here, make it much smaller. And then go into the top left renderer, velocity controls, and we can start increasing the resolution. Be careful with the setting. If you increase the resolution on too high an area, you will create way too many arrows and you will start lagging. But if you're careful, you can still go pretty far. But if you're careful, you can have very local information. And similarly, this information can also be rotated around. So let's take another one. Go. Let's rotate it and see how it affects things vertically. Look at this. You can also do it with scalar fields, but this is a little more confusing to look at. Let's take this one, make it radial. You can see what happens here as well. If you don't like the model we picked, by the way, you can also select a different model. So let's go with these little balls that let you have directions. Or you can have something very minimal, but I'll let you explore these in your own time. Now, the final view we have in all of this is one that is not really letting you explore your data for, I guess, information reasons, but it will let you see it and be proud of it. Before you use it, I recommend going into density mode. Basically, the last information is creating a 3D rendering of your world using ray marching. We're basically simulating what light would look like if it was bouncing around your cloud. But for this to work, you have to give it the right data. So in this case, it's always going to be whichever is density. If your cloud looks strange, you should pick density. The reason I'm not opening it yet is because it is quite consuming on a computer, and I'm recording this, and also I don't have a CPU. I recommend using this if you have a CPU, or if the disk is sufficiently low in resolution. With higher resolutions, the disk will look a lot better, but it will also require a lot of resources, and it will be way better to use if you have a GPU. But let's get into it. Let's open the volumetric. And here we go. Now, my computer is struggling a little bit, but here you can see the cloud. You can see a little, perhaps you can see it, but you can see a little black spot here. This is where our planet is. And if we view it from the side, you're going to see the artifacts that, if you're familiar with protoplanetary disks, you've seen this artifact before. When viewed from a side, a protoplanetary disk can look a little confusing. It's not so confusing when you think about how light works, but it is a little counterintuitive, and you get this sort of effect where it looks like an hourglass cut in half by a black band. And we're getting this because we're simulating actually how light works and bounces, like we would in the real world. So we're getting the same artifacts that you do whenever you get an actual picture of one of these. So anyways, this is all for Tauri. I hope it was clear enough. Don't hesitate to watch this video again if you're confused about how to do certain things. And I hope you enjoy using it and enjoy viewing the data itself. Thank you very much.